All right, today is lesson 1.1, sets of numbers. Our essential question is, how do I classify and order real numbers? So let's talk about some vocabulary first.
Okay.
When you hear the word set, that is a collection of items called elements. And we're going to go over an example in a minute here.
Okay.
A subset is a set whose elements all belong to another set. So for example, not bowling, pool, right? You have three different types of balls. You have solids, which are numbered 1 to 7, stripes 9 to 15, and then the 8 ball.
Right.
So pool balls are all divided into 3 different subsets. So the set of pool balls can be divided into 3 subsets.
Okay. Got it.
So then a symbol that's also really important is that circle with a line through it.
Sorry, Miss Young.
You got it? That means the empty set. That means a set contains no elements whatsoever. It's empty. Okay. So now let's go over something that's very important. You know about a term called real numbers. Real numbers are made up of 2 different types. Rational numbers, the symbol is a Q, and irrational numbers, there is no symbol whatsoever.
Okay. And the real number symbol was an R?
Yes, good job.
Right.
I didn't mention that. Correct. So now
Okay.
let's talk about the different subsets of rational numbers.
Okay.
So for example, real numbers is a set. Rational and irrational are subsets.
Okay.
Within rational, we have integers,
Yep.
which is denoted with a Z.
Okay.
Whole numbers, which is W, and natural numbers, N.
Okay.
When I think of natural numbers, I think of counting numbers. 1, 2, 3, 4, 5, 6. That is a natural number.
So nothing negative.
Nothing negative.
And not even 0?
Not 0.
Okay.
Then if you go up a step, whole numbers, all you're doing is adding in 0.
Oh,
so it's the counting numbers with 0 added.
So still 0, 1,
1,
2, 3.
correct.
Nothing negative though still.
Nothing negative.
Okay.
Then we go up another level to integers.
Okay.
Now we're adding the negative numbers. The negative, I'm going to call it negative counting numbers because it can't be it can't be a decimal.
So these are all whole numbers.
Correct.
So -5, -4,
-3,
-2, -1, 0.
0, 1, 2, 3, 4, 5, and so
Okay.
forth. Okay?
Yep.
So now let's jump over to irrational.
Okay.
Irrational, basically what that is it's a number that does not, and we're going to talk about this later, it does not terminate, meaning it does not stop, like 0.5, for example. That's considered terminating. And it does not repeat. So, for example, 1 1/3, right, would be 1.333333333.
It repeats.
It repeats. That would be rational.
Okay.
Not irrational. So an irrational number, I kind of call it an ugly number.
Okay, so like out of all these numbers, the one I actually know is pi, which is 3.1415, and then it keeps going and going and going, and it doesn't repeat.
Right.
So since it doesn't repeat and it doesn't terminate or it doesn't stop,
it's irrational.
Okay.
That's how you kind of determine whether something's rational or irrational. A rational number can be a fraction.
Okay.
It can be a decimal.
Okay.
But it must either stop or repeat.
Okay.
All right?
Yep.
So let's go on to the next page. And on the next page, I think we've covered this. It talks about rational numbers and irrational numbers. Let's just make sure I covered rational numbers. It's a quotient, which also is a ratio, a fraction of 2 integers.
We'll write down fraction.
Exactly. And the decimal form of a rational number either terminates or repeats, just like I said.
And terminates means to stop. And repeats, well,
that's exactly what it says.
Right. Okay.
An irrational number cannot be expressed as a quotient of 2 integers. It cannot be expressed as a fraction.
Okay, so not a fraction.
Right. And the decimal form of an irrational number does not repeat or terminate. Neither.
Okay.
Okay? That's how we tell. So I think if I recall, we are doing example 1.
Yeah.
And so what we're going to do now is we're going to order the numbers from least to greatest.
Okay.
And I think the first thing I'm going to have Miss Edwards write down is we want to change every single number to a decimal before we order.
Yeah, because I don't even know what square
Exactly.
root of 5 is.
So maybe let's
Okay.
write a note
So
somewhere.
we're going to say first change to decimals.
Correct. So that's what we're going to do right now. So
Whoa. First change all to decimals.
perfect. So 2.3 repeating, that's
that
already
is a
decimal. So pi would be,
3.14.
yeah, that's
Probably
good enough.
enough.
Square root of 5 would be 2.236.
And the way you know that is just by typing it into your calculator?
Thank you. Yes,
Okay.
exactly. Negative 11 over 2 is negative 5.5. And over there, that's already
Decimal's there.
decimal.
Okay.
So now we want to order it from least to greatest. But be careful. When you order it, you're going to want to change it back to its original form.
Okay, so I'm not going to write these new decimals in my
Correct.
list.
So the lowest is going to be obviously
A
the negative,
negative.
which is a negative 11 over 2.
Okay, so I don't write negative 5.5.
Mm-mm.
I go back to the
Right.
original, and I'm going to cross it off because I'm done with that one.
Perfect. Great idea.
Okay.
So the next one then would be
Let's see, 2.236,
236, which is the square root of 5.
Oh,
See? So that's, yep.
Copy.
And that is so easy to do. You want to go back to the original.
all right.
And she's going to cross out square root of 5.
Yep.
Next is going to be 2.3 repeating.
And that one is the decimal.
Mhm. Correct.
Okay.
And then 2.7652.
And we have to write all of that out.
Yes, we do.
Okay.
Because that was in the original problem. And then pi.
Okay, And pi.
We're
All
done.
right.
We've ordered it.
Mhm.
Now we're going to float. Do we have to float down or do we have enough room there?
No, we'll go down.
Okay. So now what we're going to do is we're going to classify. We ordered them. Now we're going to classify.
Okay.
So what's really easy, Miss Edward? What can we do in that real column like right now?
Well, the only numbers we know of right now are real numbers.
Exactly.
So all of these are real numbers.
Correct.
Okay, so we're going to put an X to show that all of these are real.
And remember, within the real set, there are two different types, rational or irrational. They can't be both.
Okay.
So let's determine right now whether 2.3 is rational or not. Well, let's ask two questions.
Okay.
Does 2.3 with a line over it, does it repeat?
Yes. That's
Then-
what the line means.
Then we're done. It's rational right
Okay.
then and there.
So
We-
then it's not irrational, so I'm not going to mess with that
right.
box.
However, we do have to jump down a level to integer. We have
Okay.
to double check now. Since it's rational, we now have to say, oh, is it an integer?
So is it a counting number?
And it's not.
Negative or 0 or
Mm-mm.
positive? No.
And if I say no to
Mhm.
integer, the minute I say no, I stop. Because if it's not an integer, it can't be a whole number.
Right.
If it's not a
that's-
whole number, it can't be a natural number.
Right.
So we can stop.
Okay.
So let's go down to pi.
Well, pi we said does not repeat and it does not terminate. So that's gonna
Irrational.
be irrational.
And we're done.
Can't be anything else.
Nope.
Okay.
Square root of 5. I think if we type that into a calculator,
We get
ooh, I wrote
2.2
2.236, but I think it keeps going all over the
Forever.
place.
Okay.
So
So
that's also irrational.
All right.
Mhm. And then a negative 11 over 2. All right, so we have now, what we're trying to decide is we know a negative 11 over 2 is a rational number, but now we have to say, is it an integer? And the answer is no, because it's a decimal. It's not a counting number.
Right.
That's negative or just a counting number or 0.
Okay.
So now let's go to 2.7652. We know it's real.
Yep.
Now we have to decide, well, does it stop? Does it repeat? And the answer is it stops. So
Yeah.
it would be irrational. So we put an X in rational. It's not an integer because it has a decimal.
Mm-hmm.
And if it's not an integer, it's not going to be whole or natural. And it can't be irrational. So I think we're now ready to go to the next example.
Okay.
And I think we're not going to do this
Yeah,
one.
let's
Is that
skip this
correct?
one. Yeah.
Okay.
Let's do this one in class.
Perfect. And
What about down at the bottom? Do we need to cover this?
I,
Parentheses?
you know what? I think let's go over this. Yep.
Okay.
I think that's a great idea. Okay. So what this is talking about is methods of representing intervals.
Okay.
And so you've learned a lot of this already in Algebra 1, but we're going to help you refresh your memory. When you use, and I'm going to talk about when you use an open circle versus a closed circle.
Okay.
So an open circle, what that means, so up on the 3 there, numbers where it says numbers less than 3.
Yep.
The open circle there means it includes everything less than 3, but not including 3. That's why
Okay.
there's an open circle.
Okay.
And so therefore, we have two different types of another way to represent that. You can use an inequality, which
Okay.
is, see where we wrote x less than 3?
Yep.
Or interval notation, which we're going to use either parentheses or brackets.
Okay.
And we use parentheses when we are talking about an open circle, so not including the endpoints.
Okay. So I'm just going to do this. So open circle
Mm-hmm.
goes with parentheses,
Correct?
or there's a parenthesis next to that number
Right.
that's open.
Right.
Okay. So then I guess the next thing is going to be a closed circle.
Closed
So
circle.
it'll be colored in.
Mm-hmm. And that will be a bracket.
Okay, because that's going to include
Right.
that number.
Exactly.
Okay, I'm actually going to erase one of these parentheses.
Yeah,
'Cause we
I
don't
would.
know
Good
if they'll
idea.
both be parentheses
Right.
or not.
And then, do you want to also add like
Mhm.
less than, greater than, less than or equal to, greater than, equal to? Okay.
So this first one, open, is not equal to.
Mm-mm.
Can I just write that? So
Sure.
it would just be less than, not less than or equal to.
Right.
So not equal to,
Mm-hmm.
which the opposite, the closed circle or the bracket, means it is equal.
Correct. Yep.
Okay.
Got it. The one other thing I want to emphasize is when you're talking about negative infinity and infinity,
Mhm.
since that's not really a number, it's always going to be an open circle, not an open circle. What am I trying to say? An open parenthesis.
Okay, so I see that on the first example, there's negative infinity, it's a parenthesis.
Same thing.
Positive infinity, a
Parenthesis. Exactly. So I think we're going to cover more of that in class, and we're
Okay.
going to go to the next page.
Okay.
So on the next page, I think we cover this. We do cover this right now, and then the bottom part we cover in class.
Okay.
So right now there are 6 methods of representing a set of numbers. In words,
Okay, so that's option 1.
using a number line,
Okay,
inequality,
number 3,
roster notation,
4,
set builder notation,
5,
and interval notation.
6 ways.
Now I want to emphasize roster notation is rarely used
Okay.
because it's very difficult to represent exact numbers like decimals in roster notation. Roster notation can only be represented as counting numbers.
Okay, so should I cross it off since we're not going to
Well,
use it, or
don't
leave
cross it off because it's important to understand, but we're not going to use it very
Okay.
much. So I honestly think we don't have to really say more about it because we're going to really have to cover this a lot in class.
Sure.
But these are the different examples of how we're going to represent a set of numbers.
Okay.
Now, if we go down a little bit here,
We're gonna
I think we're saving
this
that.
one.
So
Yep.
let's go to the next page.
Okay.
And I think we cover this right now for a little bit.
Sure.
Here's a notation that's very important that you're going to use a lot this year. And this is how it's represented. It means, I'm just going to read what it says.
Okay.
It represents the set of all numbers x such that, so that green line,
Mm-hmm.
vertical line is the word such that.
Hmm.
Yep. X has the given properties. So basically it's saying that X is going to be in between 8 and 15, including 15, not including 8.
Okay, for
Okay.
this specific example.
Exactly. So
Okay.
all numbers less than or equal to 15 and greater than 8. And that last part where it says X and then that lovely weird symbol, an N, that's just saying that X is an element of the natural numbers.
Okay,
And
and I
we-
see that down here.
Right. That's
Okay.
what that means. And we just want you familiar with that. You won't be necessarily having to write that in a like on a quiz or a test.
Sure.
So I think example 3 we do. Is that correct?
Yep.
Okay. So now this is what we're going to do. We are going to fill in this table right now.
Okay.
So first of all, let's just start on the first one. It
Okay.
writes it in words.
Mhm.
Numbers less than 3. So Miss Edwards is going to draw a number line right now.
Okay.
And she's going to write the number 3 down below. And if it's less than, we know it's an open circle right away.
Right.
And it's going to the,
Left.
that's
'cause
it.
it's numbers less than 3.
You're done.
Okay.
Now, inequality, you're going to write X
Is
less than 3.
3.
There's no equal sign under that because it's an open circle.
All right.
Interval notation, well, we know we're going to have 2 parentheses. One on the left because it's going to negative infinity.
Because anything less than 3.
Yes.
Okay, goes
correct.
all the way to negative infinity.
Right? And then a comma, and
Mhm.
then 3, and a parenthesis.
Because it does not include 3.
There's an
If
open
it
circle.
did, it would be a bracket.
Correct.
Okay.
Now, roster notation, what Miss Edwards is going to do right now is she's going to draw a squiggly line through all of those 3 boxes because we are not going to be able to write any of these in
Okay.
roster notation.
All right.
Set builder. Now, that's what we just talked about above. I apologize. I didn't state that. That was set builder. So she's
the
going to
very
draw
top
this.
of the page.
Yep.
Okay.
She's going to draw a squiggly line. There's
Okay,
not a
so-
lot of space here, so I apologize.
So I need the bracket.
Yep. X, and then the vertical line, all X, such that X is less than 3. So what I want to emphasize right now to make your life really easy is look at the inequality form and look at the set builder form. They are identical except for the X and the vertical line such that. That's it.
And those little squiggly
And the
brackets.
squiggly brackets.
Okay.
They are identical.
Okay.
So now let's go to the next row.
All right.
It tells us inequality, so let's go and write the words. So if it's X greater than or equal to negative 2,
Mm-hmm.
that's going to be numbers greater than or equal to negative 2.
Numbers
Mm-hmm.
greater than or equal to.
Mm-hmm.
I'm going to shorten these up here.
I like that. Very nice.
To negative 2.
Done.
Okay.
Now a number line.
Numbers greater than or equal to negative 2. All right.
Correct.
So I need my number line.
Mm-hmm.
And I need negative 2 on my number line.
Yep.
And then,
She needs a closed circle.
right, because it could be equal to.
Right.
And
And she's
greater
going
is
to
going
the right. And I call that, if you go and put your little point up
Mhm.
there for a minute, I call that my nose pointer, and it's pointing to the right, so I know my arrow's going to the right.
Okay, as long as X is on the left.
Thank you, as
Right.
long as X is on the left.
Okay.
Interval notation. Now on the
All
right,
right.
we're going to have infinity on the right, because it's
Right,
going
anything
forever to the right.
bigger. Okay,
Mhm.
so, oops, not negative infinity this time.
No, infinity.
Infinity.
And a parenthesis.
And,
And on the left, it's negative 2.
So a bracket.
And a bracket because it's a closed circle. Good.
Okay.
Well, now look, remember what I said,
Yes.
Miss Edwards?
Okay, so I just need the squiggly bracket. Then I need X
Mhm.
such that.
Right.
Which is the vertical line.
Yep.
And then I just copy this down
That's
again.
it.
X is greater than or equal to negative 2.
Done. Easy. All right, next one. It gives us interval notation. So let's do words first.
Okay.
So it's going to be numbers greater than or equal to 99. That's it.
And you said greater than or equal to because of the bracket.
Because of the bracket.
Okay. so
Correct.
Numbers.
Yep. That's fine.
Greater than or equal to
Mm-hmm.
99.
Mhm.
All right.
Number line.
Number line. Putting 99 on the number line.
Yep.
I get to do greater than or equal to, so I get a closed
Close
circle.
and to the
bigger.
right.
Okay.
And let's see.
So,
Oh yeah,
X is
greater than or equal to.
or equal to 99.
And the last one
Now, same
is
thing. So squiggly bracket.
Mhm.
X such that X is greater than or equal to 99 and squiggly bracket.
Yes. Will you do one thing for me?
I sure will.
Do you see that little opening?
Oh,
Just in case someone would say, well, there's a little opening.
there you go.
All right, next page, everyone. Example 4, we are saving for class, I think.
Yep.
And so if my memory
Alright.
serves me, we're ready to go.
Okay.
So video questions 1 and 2. Number 1, you're going to graph. Basically pick A, B, C, or D.
Mhm.
And then number 2, you're going to write an interval notation. And yes, you can do that on your phones and on your computers. And we will see you tomorrow.
Make sure you answer the questions and go back up and fill out the form that's at the top of your screen, your
Yes.
computer.
Here we go.